Hello.
Hey everyone, how's it going? Good. Great. So hope Spec is going well so far. We're going to talk to you today about building secure apps, making the most of the Slack platform, and how to keep security in mind as you are building your applications and integrations. So I'm Max Feldman. I work on the product security team at Slack. I run our bug bounty program. I work on internal feature reviews. I work on some of our app directory reviews. So if you have an app on our app directory, it may have been me reviewing it. And this is my colleague, Kelly.
Hello. I'm Kelly. I'm also with Slack's product security team. I work very closely with the app directory team to kind of ensure that our app directory is a safe place for people to continue that trust that they have for the Slack platform. So today, we're going to talk about why app security matters, which I hope that you all know as you're here, you came. Next, how we review apps, security best practices, and Max is going to talk about some of our new features with platform security that we're really excited to introduce today. And then finally, we'll open it up to Q&A. So first, why app security matters. So apps in our enterprise environments are handling highly sensitive information. They're handling our trade secrets, our unannounced deals, our features in development, and occasionally our live security bugs. Our customers are trusting us both, Slack and you, the developers, to keep their data secure. And finally, a breach can be disastrous. Nobody wants to be the next headline talking about apps as a security surface, as an attack surface. So yeah, we want everyone's imaginations to run wild and to build cool apps, but we really want to help you do it securely. So how we review apps. So we perform automated web app scanning and network scanning just as a sanity check for the security posture of your infrastructure. We'll perform manual verification of your proper scopes. So what we're trying to do here is ensure least privilege design, where we have some really broad scopes, and you have a lot of power and flexibility to choose what kinds of data your application is going to access. And we ask that you not overscope your apps and not request more data than you actually need access to build your cool integration. So if your app is overscoped, we will contact you and ask you to correct that. We'll also perform some manual testing of functionality for possible vulnerabilities and misuse of some legitimate functionality of your application. And finally, we'll perform a manual architecture review of your app. So what we're looking for, first and foremost, is this a malicious app? Is someone trying to introduce malware into your Slack platform? Second, we look for the OWASP top 10, so the most common security vulnerabilities that that app developers introduce. Third, we're looking for overly permissioned apps, again, ensuring that principle of least privilege. It's important to consider these issues even if you aren't building a public app, because you want to be mindful of opening up attack surfaces for your channel guests and insider threats. So we work really hard within Slack and within Slack security to make our platform really secure, but we just don't want to open up attack surfaces with our integrations. So what do we find? Most common vulnerabilities, cross-site scripting. How many of you know what this is or are familiar with it? Cool, great. So, as you know, with a communications tool, you are relying so heavily on user-supplied input, and you want to make sure that you are properly handling that and output encoding. Second, TLS configuration. This is a really easy one, and an easy win that you can check off just by making sure that you're up to date with the most proper protocols and cipher suites. Information disclosure is a big one that we see as well. Most commonly, this is things like leaking tokens via URLs. So again, I have another slide to talk about how to properly handle tokens because that is so important. Authentication issues, again, think about how you're handling those cookies. And just some honorable mentions, security patches and keeping up to date on those libraries and software. And debug mode in prod, again, this is an easy win. Just make sure that you turn off debug mode so that people can't flip that and leak some of your secrets. Security best practices. So token storage best practices. These are your most sensitive asset to protect. First and foremost, do not pass tokens via the URL. Let me say that again. Do not pass tokens via the URL. Pass them safely in headers and bodies of post requests. Do not hard code your tokens. Don't publish them to your code repos, even if they're private. This is a huge attack surface. We have a token nuker, and we're finding and revoking tokens from GitHub every day. And Max will talk a little bit more about that later. You want to store your tokens safely in something like Vault or pass them as environmental variables. General security best practices. Have an SDL, have a secure development lifecycle process. We recently published a blog about this, about what we use here, and we open sourced a tool that we use at Slack, GoSDL. You want to make sure that you are designing securely from beginning to end, and make sure you revisit your code whenever you're making changes. Just sanity check yourself to make sure that you're not introducing new vulnerabilities. Second, do not trust user input. This is the easiest and most viable attack surface for hackers. Again, cross-site scripting is something that we see the most because our application is user-supplied input. Make sure you're output encoding properly. Consider where dynamic data is influencing control of your application, and be aware for opportunities for code execution. Finally, get into that attacker mindset and think about how an attacker might abuse your system using legitimate functionality that you didn't even consider a vulnerability. Once you're in that attacker mindset, stop attackers before they have the chance. So I'm going to pass it over to Max now to talk about some of those new platform security features.
Thank you. So how many people here have written an app for Slack? Nice. How many have one on the app directory? OK, cool. This will be relevant to everyone for both internal and external integrators. And yeah, as Kelly said, we have a lot of things that we test when when apps are getting onto the app directory. We have a lot of those guidelines online, so our documentation is extensive. We're trying to make it bigger. If you have feedback, we also welcome that. And with that, I'm going to talk about some of the features that you can leverage to harden the security of your apps. So first, we have IP whitelisting. So this applies if you're building an internal or an undistributed integration. And it lets you limit the access to the web API to defined IP ranges. So you could, for example, limit your application to your corporate network and make sure that tokens for a particular app are only coming from within your corporate network. This can help provide defense in depth against token theft, against other breaches, for example, or perhaps token disclosure. As Kelly mentioned, we have a token nuker that sits and looks at GitHub all day and watches for tokens and deletes them and invalidates them. But if your token gets breached in another way, if it gets published in another way, it won't be able to be abused because of this IP range restrictions. And requests originating from outside the range that you specify are rejected by Slack. So they are not allowed to use the API. So the way this works, you have two IP address ranges in the OAuth and permissions pane of the application management page. So there's a restrict API token usage section that allows you to specify your whitelist. So you can use CIDR notation. You can use a particular IP. So if you know the IP range of your corporate network, for example, or if you know that there's one box with a static IP address and that's the only thing that should be performing as this application, you can lock it down there, save it, and then bam, those tokens are restricted to that IP range. So another feature, so that exists, you can make use of that. The next couple features are coming soon, but very soon, and you'll be able to make use of them. So how many of you have built a slash command before? How many of you are familiar with the verification token of the slash command? How many of you have verified that token when you receive a request from Slack? So great, that's good that you're doing that. Request signing is a feature that's coming out that's going to allow even more hardening to ensure that a request you receive is actually Slack. And it's going to allow hardening in more complex environments and situations. So it provides defense in depth and it's going to provide security even in the presence of an active man-in-the-middle attacker. So I'm going to show a diagram of that. But basically, request signing gives an extra amount of hardening, this defense in depth, over the current verification tokens. So let's say we have an environment in which there is a man-in-the-middle attacker. If you when you have an active man in the middle, it's someone who can read all your traffic. It's someone who can modify your traffic, intercept, stop your traffic. So this hacker here is somehow, or this attacker is somehow in your infrastructure before your app, and they are seeing these requests as they're coming in. The way request signing works is when Slack sends a request to you and your infrastructure, instead of just sending a verification token along, it sends a signature of that request. And a signature is something that, it's a cryptographic construct that will prevent an attacker from forging it or modifying it or even replaying it. So we start with Slack has a shared secret with you and your app, and that is what's providing the security within this signature. But when we send the request out, we don't say, here's the request and here's the token along with it, because an attacker could look at that, they could reuse the token, they could modify that request. What we send instead is basically a hash of the request and the secret. And a hash is going to be a cryptographic hash function. It's a one-way function. Can't be spoofed because of the secret. It'll have a timestamp in the request body, so it can't be replayed. So this attacker can see this whole request and they can see this signature, but they can't change the request. They can't wait later and send the request again and trick you into doing an action twice. So when you receive a request from Slack, you, using your shared secret, are able to calculate this hash, make sure it matches, so you verify this signature, and then you have a guarantee that this request, as it was sent by Slack, is what you have actually received. So even if you have more complicated infrastructure, if you have requests going through various proxies or other things, or you want to keep these things secret from your own internal users, you'll be secure against that. There's no potential for spoofing, as long as you verify the signature. So like our token infrastructure now, if you don't actually verify the token, not so great, but same with the signature. Signature works if you verify it. So along the same vein, we're also going to be releasing mutual TLS. So who is familiar with TLS or SSL or HTTPS? If you've used the internet, it's probably going on there. If you connect to Slack, it is happening. We use TLS. So this is going to be another way to continue to trust and elevate the trust of the origin of requests that you receive. So when you receive a request from Slack, you're given another way to verify that this was indeed Slack sending the request. This is going to operate at a lower level. So whereas the signature verification happens within your application logic, mutual TLS can be done at more of an infrastructure level. So we have app level, higher level for tokens, for signatures. We have infrastructure level for mutual TLS. So the server, which is you, is able to authenticate the client. So Slack is a client. It sends a request to you that says, like, hey, here's some information. When Slack sends that request out, it sends it over HTTPS, we verify, we check your certificate, and then we send the data over after establishing that connection. Now, before that step happens, you're able to authenticate that Slack is indeed Slack. So Slack will release a certificate signed by a certificate authority. You can set your infrastructure up to mandate certificate checking, so we have mutual authentication now. So right now, we authenticate you. With mutual TLS, you can authenticate us. So as we see here, Slack communicates with your app. We perform a verification. You request our certificate, and you make sure that before you even receive data, this connection is from Slack. So this offers additional security. It offers defense in depth, especially with regards to the previous diagram I showed, active man-in-the-middle attacker, someone who can modify your traffic, read your traffic. This will also provide more resilience and make things a little more robust in the face of complex infrastructure. So if you have your app routing different requests to different places, it's going to help you out in ways that provide more provide more defense in depth, and depending on like who runs parts of your infrastructure, maybe you don't want them seeing a verification token, maybe you only want a certain endpoint too. In this way, they can never spoof Slack. So this is often, depending on your infrastructure, just a switch that you flip or just a small configuration change. You don't even have to write your own code for that. So this is also coming soon. And moving to a little bit more of access control. So Kelly mentioned earlier this principle of least privilege. So you want to keep your app scoped to the lowest possible privilege that it should have. In the event of a breach, this means that if your app token gets stolen, it won't have access to more data than it should need. It provides defense in depth, and it encourages apps to be acting in a good way, following best practices. For example, if you have an app that should just be sending cat pictures, maybe it doesn't need to read all of your channels and impersonate users when it does that. So the permissions API is an aspect of workspace apps, and that what it does, it grants the serenity to more precisely manage your app's capabilities, privileges, and resources. So it's a collection of web API methods and events, API event types. So there are a variety of ways you can employ this, but basically what it offers is that you can change your permissions and access over time. And this allows for a richer and more secure experience. So let's say you start by following the principle of least privilege and you say, cool, I only need a little bit of privilege, I only need to send a message. But then you come up with this awesome new feature and you want to read messages so that you can provide more value to users of your application. You can then request it. So this provides a more seamless way to have granular access control, to ensure that you follow the principle of least privilege, but you aren't restricted from the future, where you can develop more, expand your app, but still follow principle of least privilege as you continue to develop your application. And another aspect of workspace apps is short-lived access tokens. And this is going to help with another way for you to have defense in depth and follow best practices in an easier way. So you can rotate API tokens without downtime and without forcing users to re-authenticate. And this will provide an improved experience for both internal and distributed apps. This is coming soon, but hopefully very soon, you'll be able to make use of this. And so let's say you want your tokens to rotate automatically, or you want tokens to expire every day so that you have tokens that are only living for 24 hours. You can do this in a seamless way. You'll be able to use the API and our interfaces to keep these tokens rotating. So let's say your application or your servers do get breached completely. The impact there is mitigated because all of those tokens will expire soon enough anyway. You can also rotate them in the event of a breach without negatively impacting your users. So it gives a lot of, I keep coming back to this, but defense in depth. And it also gives a way to deal with emergent situations. So you keep using the same APIs here, but there's more power to proactively rotate tokens to respond to such situations. It can also reduce the impact of unknown token leaks. So maybe one of your tokens makes it out, not GitHub, but Pastebin or some other site out there on the internet. Someone plucks it and they try and start abusing it. With frequent token rotations, the impact of an attacker doing that is limited to a very particular time frame. So instead of a token that's living for a long time, where you have to further investigate, you automatically prevent an incident from going on for too long. So this is also coming soon. So to sum everything up, there are a lot of security best practices that Kelly talked about, and you want to be following those. And the highlights there, as she said, don't trust user input. You have rich applications, but people will try and abuse them. So don't always trust what's coming in. Make sure you're thinking through it, and try and think with an attacker mindset. Think how someone would try and break your app, not just how someone will get the most value out of it. And with all of those security concepts in mind, we're trying to, and continuing to, expand our platform to offer more security features so that you, the developer, can provide these enterprise-ready apps, apps that will work in a variety of corporations, in a variety of networks, and provide security and peace of mind to all sizes of customers so that we can keep our mutual customers secure. People who use your apps are people who use Slack, and we want this ecosystem to be secure for everyone. And with that, we're going to have some time for questions and answers. Anything else to add before we move to that? Cool. So thank you, everyone. And now we have some time for Q&A.
And I think we have time for one question, actually.
Cool.
Oh, OK. One.
Wait, sorry, can you say it on the mic?
The question is, are there any plans to publish a whitelist of IPs that Slack is using? Currently, no. The nice thing about mutual TLS is you don't need that whitelist because you'll always be able to verify that Slack is the one talking to you. So at an infrastructure level, you can trust Slack without actually knowing the IP. OK, sorry, that's time. We'll be hanging around for the rest of the conference. Please feel free to come talk to us. And thank you, everyone.
Thank you.